Good day everyone. Welcome back to another video in the Azure Databricks series. In today's video, we will dive into a crucial technique for cost optimization in Azure Databricks by leveraging the Delta table vacuum command. We will explore how to clean up old Parquet files that are no longer needed, which will help reduce the storage costs associated with your Delta tables. Let's get started. First, let's talk about the delta vacuum. When we modify delta tables, whether we are inserting, updating, or deleting data, Parquet files that store the data can accumulate over time. This increases the storage cost as these Parquet files will be placed in the storage account. Yeah, especially if those files are no longer required. The vacuum command helps us by removing old, uncommitted data and the Parquet files which are no longer required, and but it will make sure the necessary files are kept. Yeah, by doing so, we clean up unnecessary storage and reduce overall storage costs. Now, what we'll do is let's look at the delta table that we are going to work here. Yeah. So under the Hive master, I have this schema called Shaurya, and below that you have this table called delta table called employee. Yeah. As soon as I clicked on it, we are able to see the overview of this particular database, this particular table on the right side. Yeah, so I will move this one, and if you see here, the data source is delta, which means like it is a delta table. Yeah, and if you look at the size here, yeah, the size is like close to 248.5 MB. So the size of this table is close to 248.5 MB. What I'll do after showing the details of this particular table, delta table employee, I will take you to the storage account that holds this particular table, and then I will show you how much space you have on the individual files, and then we will run Python script in the notebook to see how much space that this particular folder which holds this employee table is having. Yeah, we will look at that one. Yeah, so right now if you look at this particular delta table, the size is close to 248 MB. Let's keep it as 250 MB. Okay, and I don't think we need to look at the sample details. Yeah, if you look at the details here, yeah, if you look at the details here, what I'm able to see is this is on the container delta tables, and then the folder is Shaurya employee. Yeah, so now if I look at the history, you can see that there are so many operations here. Yeah, so 11/10 2024 version 0 is when we created this table. Yeah, and after that, if you can see, we have a lot of writes, updates, deletes, and things like that. Okay, so now we know that this particular table is close to 248.5 MB. Let's treat it as 250 MB. Now what I'll do is let's go to our storage account here. Yeah, and then let's click on the container. Let's click on this container called delta tables. Yeah, and inside that you have this folder Shaurya employee. Yeah, and then now if you see here, we know that the table size is close to say 250 MB. Yeah, 248.5 MB. But if you look at the files inside, there are so many files here. Yeah, so there are so many files here. If I click on load more, yeah, there seems to be a lot of files. Lot of all these things are Parquet files. Yeah, I will show you that one as well. Yeah, you see this? All these things are Parquet files. Yeah, and all these Parquet files are created as part of your version there. Yeah, so depending on the amount of operations or the changes that we have done, you will have that many Parquet files. Yeah, so there are so many files, so I just don't want to show you everything, but there is huge. Yeah, the table size is just 248.5 MB, but there seems to be huge lot of files. Yeah, so what happens is in reality on a production environment, let's consider you have a table, a delta table that is used for staging, or let's say like you have a highly transactional delta table. Yeah. So what happens is like whenever you make changes, like you do a lot of inserts, deletes, updates, and things like that, in order to maintain the version, in order for you to make the time travel, what happens is like you will get these Parquet files created, which is a great concept to be frank. But the problem is like when when this process goes on for some time, and you have lot of Parquet files created, and then you might look at the version history. What will happen is that you will have so many versions for that particular delta table, which you will never ever use as far as the time travel is concerned. Yeah. So what you need to basically do is like you need to ensure that you clearly understand what is the time frame, or what are the operations that needs to be there as far as the time travel is concerned. You need to come up with a duration. Yeah. Let's say more than 7 days, or more than 30 days, or more than a quarter, like close to 3 months. But as soon as you come to this particular condition that this particular delta tables, or this all the delta tables in this schema has to have this time travel capacity for this specific duration, then what we can do is like we can utilize this vacuum command and make sure like only the required amount of Parquet file to satisfy your time travel requirement is only there. That way, what you're going to do is like you are going to reduce a lot of Parquet files and ensure you are paying for what you are using. That is like you will bring down your storage cost by reducing the amount of files that is present, and in the way you will be reducing the amount of the size that this particular storage account is utilizing. Yeah. So now if I take another example, let's say I have a staging table which basically works kind of a placeholder, which basically gets the data, huge amount of data, and then what it basically does is like it moves that particular data from that delta table onto another data table. And this data table is just a placeholder, but it gets a lot of data inside, and there are a lot of data manipulation happens, like insert, delete, and things like that. For tables like that, since you're going to get the data every day, and I don't think you require any kind of time travel in that. Even if you require a time travel, it will not be more than 1 day per se. Yeah, because every day you're going to get the new data, and then you need to move it to another delta table. In that case, what you can do is like you will basically be able to reduce the amount of Parquet files depending on your requirement. Yeah. This example, this demo that I'm going to do is on a table that is specifically tailored for that. That is, it's a kind of a staging table. In my case, I'm just going to do every 1 hour. It's gonna get several million rows. Like in my case, it got close to 128 million rows. Yeah. And then now it got reduced to a greater extent. I will show you guys on that particular thing, and then we'll take it forward. Yeah. And now if I now that you guys have looked at it, like it's this particular thing, this particular storage account has got too many Parquet files. What we'll do is like let's go to the notebook that I'm going to use now. Yeah. So now what I'm going to do is like I'm going to show you the number of rows that we have on this particular table called Shaurya.employee. And if you see here, like I've close to like 2.5 million records here. Yeah. And at one point in time, let's say, since I told you guys like it's a kind of a staging table. Yeah. If you see here, we have close to like 128 million. Like once we had close to like 128 million, that is when I completed my full load onto this delta table, and then I moved some of the required rows onto a different delta table, and then I currently have removed say like 126 million rows, like 125 million rows, and I just have 2.5 million, and that's the reason table size is in some MB. Yeah, if you see here, the delta table employee that is in Shaurya schema, it is just like 248.5 MB. Yeah, but the underlying files on that particular storage account is too huge. Now what we'll do is like, let's look at like what is the actual size there. Yeah. So let me execute this query. If you look at here, I'm basically looking at this Shaurya employee folder inside this Delta tables container. Yeah, I'm basically getting the size in KB, MB, and GB. Yeah, let's execute that. Yeah, if you see here, what we are seeing is like it is close to 23 GB, yeah, 23,888 MB. So let's keep it as 23 GB, yeah. So what we are basically seeing, the table size on papers, like what you have exactly is like just 248 MB, yeah. But the size of the storage account, that is the folder Shaurya employee inside the container Delta tables, is like close to 23.3 GB. It's like kind of insane. Like, so we are talking about 200 MB and 23 GB here. If you do the math, it would be like several X. That is like too huge, yeah. But if you look at the production, if you have something of this sort, what will you see is like it will be several GBs or terabytes as well. Yeah, you will be able to save lot of storage, to be frank. Yeah, believe me, on production when you're doing this vacuum for the first time, the storage space saving would be really really insane, and then also the cost that you're going to save because of this activity will be really huge. When you guys do it, then you will know. Yeah, so now what I'm going to do first is like I'm going to execute this vacuum command as a dry run. Yeah, before we actually delete any files, it's always a good idea to perform a dry run. The dry run will show us which Parquet files would be deleted if we ran the actual command without making any changes to our data. These steps really, really helps us assess the impact. Yeah. So now let's execute this. Yeah, you will get an error. I will show you that. So it's basically like it basically tells like are you sure you would like to vacuum files with such a low retention period? Yeah, so I've given like maybe like 1 minute here. Yeah, it is 0.017 hours. You multiply it by 60, it will be like close to 1.2 minutes. Yeah, it basically tells like if you have writers that are currently writing to this table, there is a risk that you may corrupt the state of your Delta table. Yeah, so it is basically telling like when you are doing this vacuum and if you have any writers into this table, it's gonna have a huge impact. Yeah, this you cannot do it on a production. I would never ever recommend this to be done on the production. Since it is a demo, I'm basically trying to showcase like what vacuum is. That is the reason I'm doing it. But in production, you can't do it. Yeah, so you basically have to maintain that. At least the 7 days of data. Yeah, 7 days of data in the sense like that version kind of thing. Yeah, as far as the Parquet files are concerned, it is if you're pretty sure you can reduce below that 7 days, you can go and do that. But I don't think you will be able to do something of this sort because for me it's a demo. I'm pretty sure there will not be any writers. Yeah, on a production or a development environment, if multiple people are using that, there is no way we will be able to ensure that. So it's very, very critical. You understand the impact, and I just don't want you guys to try saving a lot of space and then end up corrupting the existing table. So just keep that as a warning in your mind. Yeah. Now, since it is a non-prod, it's a demo system here. So what I'm going to do is like I'm going to disable this retention duration check, which basically gives you this particular information here. Yeah. So that is done. So now what I'm going to do is like I'm going to run this a vacuum table retain 1.2 minutes dry run. Yeah, 0.017 is close to 1.2 minutes. So I'm executing it. And then if you see here, these are the Parquet files that will be affected. Yeah. So what you can do is like maybe like if you want to look at it as we have done it before, you can have a look and then understand how much space you're going to save and things like that. Yeah. I'm not going to do that here. Yeah. So these are the things. Now what I'll do is like I will go to this particular command and then I will run that. But yeah, as you can see, the dry run has identified several Parquet files that are no longer required. Yeah, it also tells us the amount of storage we can recover by running the actual vacuum command. This you basically can use to the business stakeholders to tell them like this is what you're going to save. Yeah, but it requires some sort of manual work, or again you can write a Python script and get the required thing. Shouldn't be a problem. Yeah. This is really a crucial part of cost optimization process. Understanding what we will save before we execute the final command, that is really going to help you. Yeah, so you can get the required details from here and then take it from there. So it is basically telling like 328 rows affected, so which is close to like 328 Parquet files. Yeah, so you can do it manually and then you can take it from there. Now what I'm going to do, I'm going to run the actual command. Yeah, you don't have that dry run here. Yeah, I'm just going to execute it. Let's wait for it to complete. Deleting untracked files and empty directories. So you can see that. Yeah, so in my case, this is completed. Yeah, this is completed. So now what I'll do is like before going to my storage account, let's execute this query. So what I'm seeing is like before the vacuum, we were able to see like this storage account was 23.2 GB used. Yeah, so now let's execute it and see like what would be the size. Now, if you see, the size underscore GB is 0.24, and now if I look at the size underscore MB, which is 248.4, yeah, so it is like close to what we have on this particular table in this portal. Yeah, so what we have done basically like we cleared it out and then we just have like 248.4 MB, so we saved close to 22 point some GB of space from that storage account. Yeah, now let's go to this storage account, that is the container delta tables, and then we had this. So what I'll do is like let's do a refresh here. Yeah, and then you see you don't have several Parquet files. Now I brought it down to the required Parquet files. Yeah, so this way we were able to remove a lot of unrequired Parquet files and then have just the required Parquet file. Now that we have cleaned up our Parquet files, let's talk about a few best practices. Vacuum should be run regularly, especially for tables where data is frequently updated. However, be cautious about how many days of data you retain. If you want to maintain time travel capabilities to query old versions of your Delta table, ensure you are retaining enough files to support that. To wrap up, we have seen how using the Delta vacuum command can significantly reduce storage costs by cleaning up unnecessary Parquet files. This is one of the most effective strategies for cost optimization in Azure Databricks, especially when dealing with large data sets. Remember to always perform a dry run before executing the actual vacuum to ensure that you are only removing files that are no longer needed. Thank you for watching. If you found this video helpful, please give it a thumbs up and consider subscribing to the channel for more tips and tutorials on Azure Databricks. Feel free to leave your questions in the comments below, and I will see you in the next video. Jai Hind.